students. Today we will learn the inverse trigonometric functions problems. In previous class we learned formulas. Today we will see the problems. So on completion of this period you would be able to prove the equations involving the inverse trigonometric functions in which the sum and difference of two inverse trigonometric functions in terms of another inverse trigonometric function known to unknown. Have you given the value of trigonometric function of a variable? Do you know finding the value of another equivalent trigonometric function involving the same variable? Given sin x equals to 5 by 12, what is the value of tan x? And like remaining questions. Example 1. Prove that sin inverse of 5 by 13 plus sin inverse of 3 by 5 equals to sin inverse of 56 by 65. The solution is let sin inverse of 5 by 13 equals to a, then sin a equals to 5 by 13, and cos a formula is under root of 1 minus sin square a, then cos a equals to 12 by 13. Similarly, sin inverse of 3 by 5 equals to b, sin b equals to 3 by 5, cos b equals to root of 1 minus sin square b, cos b equals to 4 by 5. We know that sin a plus b equals to sin a cos b plus cos a sin b. After substituting, we get a plus b equals to sin inverse of 56 by 65. In place of a and b, if we substitute, we will get the required proof. Another question. Prove that sin inverse of 3 by 5 minus cos inverse of 12 by 13 equals to sin inverse of 16 by 65. Same, let first term consider as a, then we get sin a, from that we know cos a, and similarly second term let it is b, and cos b equals to 12 by 13. From that we know sin b value, that is 5 by 13. Sin of a minus b equals to sin a cos b minus cos a sin b. If we substitute, then sin of a minus b equals to 16 by 65. A minus b equals to sin inverse of 16 by 65. This is the RHS, hence we proved. Another example, prove that sin inverse of 3 by 5 plus cot inverse of 5 by 3 equals to cot inverse of 11 by 27. Take LHS and first term consider as a, then sin a is 3 by 5. From sin a we know cos a is 4 by 3, and let second term is a b, then cos b equals to 5 by 3. Sorry, cot b, not cos, it is a cot. Second term is a cot. So cot of a plus b formula is cot b cot a minus 1 by cot b plus cot a. So after substitution we get cot of a plus b equals to 11 by 27. Then a plus b equals to cot inverse of 11 by 27. This represents RHS, hence we proved. And another question, prove that sin inverse of 3 by 5 plus sin inverse of 5 by 13 equals to cos inverse of 33 by 65. Same as above we did, take LHS, consider first term as A, and from that cos A we can find 4 by 5. Second term is B, and from that cos B equals to 12 by 13, and take the formula cos of A plus B, because right side term is in the cos term, so take this formula cos A cos B minus sin A sin B. Substitution, after we get 33 by 65, then A plus B equals to cot inverse of 33 by 65. This is the required answer. Prove that cos inverse of 8 by 17 minus cos inverse of 21 by 29 equals to sin inverse of 155 by 493. Take LHS and consider first term as A. From that we know sin A, and consider second term as a B. From that we know sin B is 20 by 21. Near right side term is in terms of sine, so take the sine formula, that is sin of A minus B equals to sin A cos B minus cos A sin B. After substitution we get 155 by 493. Then A plus B equals to sin inverse of 155 by 493. This is the RHS. Next question, prove that sin inverse of 3 by 5 plus sin inverse of 5 by 13 equals to tan inverse of 56 by 33. Consider first term as A. From that tan A we can find as a 3 by 4, and consider second term as a B, and from that tan B we can write 5 by 12 by diagram. Then we know that tan inverse x plus tan inverse y equals to tan inverse of x plus y by 1 minus x. After substitution we get tan inverse of 56 by 33. This is the RHS. Summary. In this session you learned how to convert the sum or difference of two inverse trigonometric functions into another inverse trigonometric function, and quiz. So this is based on the formulas. You can easily find the answers. So answer is D, and second answer is here second answer is not given. Till we can find if cot inverse x, we can write tan inverse of 1 by x. Tan inverse get cancelled, then answer is B. Next, do the assignment problems, and if you have any doubts ask me.